What if your GPS suddenly failed, mid-drive, mid-flight, mid-mission? What if your cloud backups vanished in seconds? What if AI systems guiding hospitals, markets, or even your home assistant just went dark? What if this isn't science fiction, but a forecast? The sun is entering a violent phase. Its surface is boiling with energy, twisting magnetic fields into coils of tension. When they snap, they hurl billions of tons of charged plasma into space. These eruptions are called solar flares and coronal mass ejections, CMEs. They're not new, but their scale, frequency, and potential impact are escalating. In 1989, a single CME knocked out power across Quebec. In 2003, satellites went blind. Now imagine that, amplified and aimed at a world where everything is connected. We've built our modern society on GPS timing, cloud computing, and real-time AI. All three are vulnerable. Because solar storms don't just disrupt, they cascade. They warp magnetic fields, overload circuits, twist data. What starts as a flicker in the sky could spiral into digital darkness. And according to NASA and NOAA, Solar Cycle 25 is already stronger than expected. Its peak? Just around the corner. Experts aren't asking if, but when. And when it comes, will we be ready? Impact on global GPS systems. Let's start with something you use every day, even if you don't think about it. GPS. Not just maps on your phone. GPS powers everything from rideshare apps and weather forecasts to airplane navigation and financial transactions. And here's the problem. GPS is incredibly vulnerable to solar activity. Here's how it works. Above the Earth, a network of satellites sends precise timing signals down to the ground. Those signals bounce around between satellites, Earth stations, and your devices, helping them figure out exactly where you are. But those signals don't travel through empty space. They pass through the ionosphere, a layer of the upper atmosphere filled with charged particles. During a solar flare or a CME, the sun blasts extra energy toward Earth. That energy supercharges the ionosphere, throwing off the timing and accuracy of GPS signals. Imagine you're trying to hear a friend in a quiet room. Now imagine trying to hear them during a thunderstorm. That's what GPS satellites face when a solar storm hits. The result? Your GPS can be off by meters or even kilometers. In 2017, a moderate solar storm caused GPS errors of up to 50 feet. That might not sound like much until you're landing a plane, guiding a ship, or coordinating emergency services. But it goes deeper. GPS isn't just about where you are. It's also about when. Banks, stock exchanges, power grids, all of them rely on GPS timing to stay in sync. The signals keep everything from ATMs to cell towers to cryptocurrency ledgers operating in harmony. Without that precise clockwork, delays, errors, and shutdowns start to pile up. Think of it like this. GPS is the quiet heartbeat of our digital world. Solar storms throw it out of rhythm, and the technology that supports GPS is already under stress. The number of satellites is growing. The demand for speed and accuracy is rising. But space is getting noisier, and solar storms are one of the loudest disruptors out there. In severe cases, the ionosphere doesn't just distort signals, it absorbs them, meaning your GPS doesn't just become inaccurate, it goes completely dark. Now, multiply that across industries. Agriculture loses its precision in automated harvesters. Logistics companies misplace shipments. Telecom towers fall out of sync. Even autonomous vehicles could lose orientation in real time. In short, a single solar event has the power to blind the system that guides everything. And it's not hypothetical. In 2015, A geomagnetic storm disrupted GPS signals over North America for more than 2 hours. Pilots had to rely on backup instruments. Surveyors had to postpone work. Even drone flights were suspended in affected areas. Now imagine a storm 10 times stronger. That's not science fiction. It's part of our near future, if predictions about Solar Cycle 25 hold true. So what can we do? Governments and private companies are working on improvements like better shielding, smarter satellites, and hybrid systems that combine GPS with ground-based backups. But deployment is slow, and awareness is even slower. Most people don't realize how much they rely on GPS until it stops working. The takeaway? GPS isn't just about getting directions. It's the invisible thread tying together our digital infrastructure. And solar flares can snap that thread in an instant. Cloud and real-time AI paralysis. Imagine this. You're finishing a work project on Google Drive. Your files vanish. You try to reload. Nothing. Your smart speaker won't respond. Navigation apps freeze. Banking apps give error messages. And behind the scenes, airports, hospitals, supply chains are blinking red. It's not a cyber attack. It's not a server glitch. It's the sun. Today, cloud computing is everywhere. We store our documents, photos, medical records, even legal contracts in the cloud. But the cloud isn't a magical place. It's data, housed in massive physical servers across the planet. And those servers rely on uninterrupted power, precise timing, and stable connections to communicate with each other. A powerful solar storm can disrupt all three. It can trigger voltage spikes, damage hardware, and interrupt fiber optic relays. Worse, it can fry the satellites that route traffic between data centers, especially in remote regions. Now, add real-time AI to the picture. Many AI systems today don't live in your phone or laptop. They run in distant data centers, fed by real-time data from the cloud. Your smart assistant uses cloud AI to answer questions. Your smart home adjusts temperature using cloud-based logic. Your route to work calculated by traffic AI running on remote servers. Emergency services coordinated via cloud-driven logistics platforms. Patient monitoring in hospitals, often synced to off-site AI analytics for anomaly detection. When a solar storm hits, these systems don't just slow down. They can shut down because they weren't built to operate in isolation. They expect data. Clean, continuous, accurate. Without it, even the smartest system becomes blind, deaf, and useless. Here's how the dominoes fall. Satellites are hit first, scrambling global connections. Power surges hit server farms, many of which may lack shielding against geomagnetic disturbances. Data packets are delayed or corrupted, leading to cascading errors. Real-time AI models begin to misfire, making poor decisions or no decisions at all. Critical operations, traffic, finance, healthcare, are delayed, misdirected, or stalled. And unlike human teams, AI doesn't always know how to fail gracefully. The result? A world still technically online, but no longer coherent, where automated decisions go missing, or worse, go wrong. In 2023, a minor solar event caused brief connectivity losses across polar flight paths. Pilots had to rely on traditional radio comms. Now imagine that on a global scale, affecting thousands of flights, ports, surgeries, and factories all at once. And remember, AI is only getting more embedded. Self-driving logistics, AI stock traders, AI diagnostics. All of them depend on real-time cloud access. So when that link is broken, it's not just an inconvenience. It's a failure cascade. And here's the deeper concern. Most cloud and AI infrastructures weren't designed with solar resilience in mind. They assume uptime. They assume precision. They assume space weather isn't their problem. But the sun doesn't care. The bottom line? A major solar storm won't just make Netflix buffer. It could freeze hospitals, confuse air traffic, wipe trading data, and leave billions of smart devices dumb and silent in a world that suddenly feels very analog. The domino risk, AI blackout cascade. When AI systems go dark, they don't just stop working. They take entire networks down with them. This isn't just a technical issue. It's a cascading failure that can ripple through our entire digital ecosystem. It starts small. A solar flare strikes. Satellites are momentarily blinded. Timing signals jitter. Cloud servers struggle to sync. Then one AI system pauses. Maybe traffic coordination in a major city. Signals don't reach smart stoplights. Cars begin to reroute blindly. Congestion escalates. Emergency lanes clog. Delivery routes are thrown off. Delays pile up. Meanwhile, a logistics AI that relies on those same data streams begins feeding outdated information to distribution hubs. Warehouses misplace inventory. Shipping trucks go to the wrong locations. Retail chains start seeing empty shelves, not because the goods don't exist, but because the system lost track. Now jump to hospitals. AI-powered monitoring systems can't access patient data from the cloud. Alarms don't trigger. Vital signs aren't flagged. Doctors switch to manual mode, slowing down urgent decisions. At the same time, call centers using AI to triage customer support freeze. Users flood systems trying to get updates. Service portals go down. Confusion spreads. Not because the infrastructure is physically broken, but because the intelligence layer is offline. This is the nature of an AI blackout cascade. Each system, built for efficiency and speed, is deeply connected to others. And as each one fails, one after another, the pressure builds on the rest. This isn't speculation. In 2021, a localized server failure at a major cloud provider caused dozens of AI-driven services, from smart homes to autonomous drones, to stall across multiple countries. Now imagine a global-scale version of that, triggered by a solar storm. The problem lies in how modern infrastructure is designed. It's modular, it's interdependent, it's fast, but not always resilient. When AI handles everything from irrigation to air traffic, the margin for error shrinks. And when multiple AIs go blind at once, systems begin to contradict each other. Imagine a port authority AI telling ships to dock, while a traffic AI halts container transport. Meanwhile, an inventory AI flags false shortages, and a payment AI, confused by mismatched timestamps, refuses to authorize transactions. Each of these decisions is logical in isolation, but together, they create chaos. And because so many of these systems operate invisibly, the warning signs often appear after the damage is done. You don't see the flaw in the algorithm. You just notice your flight's canceled, your package is delayed, your street is gridlocked, your app is frozen. This kind of systemic failure isn't caused by a single AI crashing. It's caused by many AIs failing simultaneously, each dependent on the same fragile timing and data networks disrupted by solar activity. And here's the real danger. The longer the blackout lasts, the harder it becomes to restart the system cleanly. Data desyncs. Backups become inconsistent. Some AIs may reboot with false inputs, leading to even worse decisions. The cascade doesn't stop at traffic or healthcare or logistics. it can spread to the financial system. Because when AI and GPS are intertwined with stock trades, digital payments, and global banking, a blackout doesn't just delay your Uber, it shakes the foundation of the global economy. The threat to AI and GPS-driven financial systems. In 2010, the world watched in shock as the US stock market plunged nearly 1,000 points in minutes, an event later known as the flash crash. No bombs, no hackers, just a glitch in automated trading systems. Billions vanished, then reappeared, almost as quickly. It was a warning. The financial world is faster than we can comprehend, and more fragile than we'd like to admit. Today, that fragility has only deepened. Modern finance runs on timing. From stock trades to blockchain updates, from ATM withdrawals to credit card transactions, every action depends on precise synchronization. And that synchronization depends largely on GPS. Why GPS? Because it offers extremely accurate time signals, nanosecond-level accuracy that coordinate everything from bank servers to high-frequency trading platforms. It keeps global exchanges aligned. It timestamps trades. It validates blockchain entries. Now, layer AI on top. Algorithms analyze vast amounts of market data in real time. They forecast trends, detect fraud, balance portfolios, and automate decisions at speeds no human could match. But AI systems don't just need data, they need it now. They rely on continuous, real-time inputs. And many of those inputs are location-based, time-stamped, and cloud-delivered. When a solar storm hits, that chain breaks. GPS signals can become erratic or vanish entirely. Cloud latency increases. Market data streams get interrupted, delayed, or corrupted. AI models may start misfiring, not from bad logic, but from bad inputs. And in a system where milliseconds matter, confusion spreads faster than correction. Picture an automated trading AI misreading a price signal due to a delayed timestamp. It sells when it should hold. Other bots follow, amplifying the mistake. A small glitch becomes a market-wide shockwave. Now, scale that up to a global level. Central banks, insurance firms, cryptocurrency exchanges, all of them depend on real-time synchronization. Even settlement systems that finalize transactions across borders can be thrown off by a fraction of a second error. And here's the catch. Financial systems are tightly coupled. When one part wobbles, the rest tremble. Contagion is built into the architecture. Of course, these technologies also offer incredible benefits. AI enables faster fraud detection. GPS ensures transparency in logistics-backed financing. Cloud computing democratizes access to financial tools. But those benefits come with a hidden trade-off: increased sensitivity to disruption. The smarter the system, the more dependent it becomes on clean, uninterrupted data. And while regulators worry about inflation, debt ceilings, and interest rates, the sun doesn't wait for permission to flare. Unlike past centuries, when banks relied on paper ledgers and in-person trust, today's markets depend on digital consensus, an agreement between algorithms, servers, and timestamps. Disrupt that consensus, and you don't just freeze trades, you shake public confidence. And confidence is everything. In the end, a single solar storm could do what recessions and bubbles often cannot: undermine faith in the very systems meant to ensure stability. AI is a defense against solar storms if we prepare now. Let's flip the script. What if AI isn't just vulnerable to solar storms, but one of our best tools to fight them? Across the globe, Scientists and engineers are building systems that use artificial intelligence to monitor the sun, detect early signs of solar activity, and deliver real-time warnings. Think of it like a space weather radar, driven not by humans staring at screens, but by learning machines that never blink. One such system is NASA's Solar Dynamics Observatory, SDO. It continuously watches the sun in high detail, capturing data on temperature, magnetic fields, ultraviolet radiation, and solar flare activity. But the volume of information is staggering. No team of scientists can analyze it fast enough to act in real time. That's where AI steps in. Machine learning models, trained on decades of solar observations, can now detect patterns that often precede solar flares or coronal mass ejections. They sift through noise to spot weak signals, the subtle twists in magnetic fields, the flicker in X-ray emissions that hint at an impending event. In 2020, researchers from NOAA and Stanford collaborated to develop an AI system that could predict solar flares with up to 85% accuracy, hours in advance. That early warning could be enough to reroute flights, power down satellites, or isolate critical parts of the electric grid before impact. And that's just the beginning. Other projects are exploring how AI can simulate the propagation of a solar storm once it begins, forecasting which parts of the planet will be hit, when, and with what intensity. This could allow governments and corporations to pre-stage defenses, activating shielding on satellites, delaying sensitive financial transactions, or switching cloud infrastructure to more resilient zones. AI can also help on Earth. Smart grid systems can use predictive models to reroute energy flow around vulnerable transformers. Telecom networks can switch traffic to more stable ground-based pathways. Even emergency services could be guided by AI-informed impact maps, prioritizing areas most likely to be disrupted. Importantly, these systems don't just react, they learn. Every solar event adds to their database, improving forecasts for the next one. The more we invest in these tools now, the more robust our defenses become tomorrow. But timing is everything. Building, testing, and deploying solar-resilient AI isn't something that happens overnight. It requires coordination between space agencies, tech companies, power providers, and policymakers. It means treating space weather with the same seriousness we treat hurricanes or cyber attacks. Because unlike in the past, we now have the technology to prepare. We can forecast, we can adapt, we can build systems that don't just survive the next solar storm, but anticipate it. And if we get it right, AI won't be the weakest link, it will be our shield. For decades, scientists have studied the sun, measuring its cycles, mapping its flares, tracking its influence on Earth's magnetic shield. What we know today is built on generations of observation, calculation, and space-borne discovery. And what we've learned is clear. The sun is not constant. It breathes in cycles, roughly every 11 years, its surface activity rising and falling like tides of fire. Right now, we're climbing toward the peak of solar cycle 25, and it's proving to be more intense than expected. Stronger flitters, more frequent CMEs, more chances for disruption. We've seen how these storms can ripple through our systems, knocking out GPS, scrambling cloud services, and sending AI into cascading confusion. Each one a thread in the fabric of modern life, each one vulnerable to a burst of space weather. But this isn't just a list of risks, it's also a moment of choice. Because we're not powerless. We have the tools, AI, data models, early warning systems. And we have the knowledge to act, if we act in time. Think of it like this. We've built a glass city in the path of a storm. But now, we know the wind is coming. The question is, what will we do with that knowledge? Preparing for solar flares isn't just about satellites and servers. It's about protecting hospitals, airports, schools, people. It's about building resilience into the nervous system of a digital civilization. So if this video sparked a question or made you pause to wonder about the quiet power of the sun, consider sharing it, or simply keep watching, keep learning. Because in the end, the more we understand what's above us, the better we can safeguard what's around us. Thanks for watching, and until next time, stay curious, stay connected. We're all under the same star.